In the last lecture, we have learned about the addition of vectors. We know that if we have two vectors A and B, so if we have two vectors A and B acting at a point, then the resultant is given by the diagonal of the parallelogram. So here A plus B will be equal to this diagonal R. Hence your R is equivalent to A plus B. So this is from addition of vectors, adding two vectors. Now in resolution of vectors, we can resolve one vector into two components, that is along the x-axis and along the y-axis, or in other words, we can split or break up a vector into two components. One is along the x-axis, another one is along the y-axis. So here, instead of adding two vectors, we are going to split or break or divide one vector into two vectors. So let us draw first the y-axis and the x-axis. So y-axis and the x-axis. Now any vector, say A. Now this vector is in this direction. Now this vector can be split into two parts. One is this vector which is along the x-axis. So I'll denote this as AX vector, and another one is this vector along the y-axis. So I'll denote this as AY. So we have a vector A. It is split into two parts, AX and AY. So again, this is like the parallelogram. So here A vector is equivalent to AX vector plus AY vector. Okay, so this is known as the component along the x-axis, or the horizontal component, and this is known as the component of the A vector along the y-axis, or the vertical component. Now we know that a vector can be denoted as magnitude and direction. We know that any vector, suppose R vector, this can be written or denoted as R cap. R is the magnitude of this R vector, and R cap is a unit vector. It is the direction of this R vector. So similarly here, AX and AY also, you can write this in this form, one having magnitude and direction. So here, instead of this AX vector, I can write this as AX, which is the magnitude of the AX vector, and a unit vector I cap. Now we use this I cap to denote a unit vector along the x-axis. So this I cap is always in the direction of the x-axis. So this I cap, okay, you can write this as, or in this way. So this is your I cap, that is a unit vector in the direction of the x-axis. So similarly with this, similarly with your AY vector, so instead of AY vector, I'll write the magnitude AY and the direction. Now for y-axis, the direction is given by a unit vector J cap. So remember that J cap is a unit vector along the y-axis. Hence your AY vector is equal to AY J cap, and your ax vector is equal to ax I cap, and these unit vectors I and j, okay, they are along the x-axis and the y-axis. And the definition of a unit vector, okay, you can define a unit vector as a vector which has a magnitude of 1 unit only, and that it points only in a particular direction. So it only gives you the direction. So if you take the magnitude, that is, you just take the modulus of this I cap, then this will be equal to 1. So this is read as magnitude of I cap is equal to 1 unit. Similarly with j cap also is equal to the magnitude of j cap is equal to 1. And if we have the z-axis also, then the magnitude of the unit vector of the z-axis, which is represented by k vector, so the magnitude of this k cap, this is also equal to 1. Okay, so remember that the unit vector along x-axis is represented by I cap and the magnitude is equal to 1. The unit vector along the y-axis is represented by j cap and the magnitude is equal to 1. And the unit vector along the z-axis is represented by k cap and the magnitude is equal to 1. So remember I, j and k. I cap, j cap and k cap. These are unit vectors along x-axis, y-axis and z-axis respectively. Hence this a vector here, this can be written as, so a vector, this is equal to ax, the magnitude of the ax vector, I cap plus aoi j cap. So a vector is equal to ax I cap plus aoi j cap. If we have the z-axis, then your a vector will be equal to ax I cap plus aoi j cap plus az k cap. Okay, but since in this chapter we are dealing with motion in a plane, your a vector is equal to ax I cap plus aoi j cap. This is sufficient enough. Now this ax is the magnitude of the ax vector, that is the distance from here to here, and this ay is the magnitude of the ay vector, which is the distance from here to here. Now we'll actually have to find the expression for ax and ay, and we can find that by using trigonometry. So here this vector a is in this direction, and let us say this vector a makes an angle, remember this angle theta, with the horizontal direction, that is with the x direction, or this I cap. So this theta, remember, is the angle in which a vector makes with the horizontal direction, in this case the x axis. So the magnitude of this ax vector is this distance from here to here, that is from say O to P. So O to P will give you the distance or the magnitude of the ax vector, which is this ax. And let us say O to Q, from here to here, is the magnitude of the vector aoi, or is this ay. And ar, we can write this ar represents the magnitude of the a vector. Now in trigonometry, your cos of theta is equal to the base divided by the hypotenuse. So here in this triangle ORP, if you look at this triangle ORP, then the cos of theta, this is equal to the base, which is OP, divided by the hypotenuse, which is OR. And this OP is the magnitude of the AX vector, which is this AX. So I can write this as AX. And this OR is the magnitude of the A vector, and the magnitude of vector A is given or denoted by A. So here cos theta is equal to AX divided by A. Now by cross multiplication, what we'll have is, so I'll write this cos theta here. So your cos theta, so cos of theta, this is equal to AX by A. So by cross multiplication, you have A here. So here your AX now will be equal to A cos of theta. So this is the horizontal component, the magnitude of the horizontal component, and it is equal to A cos theta. Now similarly with the horizontal, so I'll write this one here first. So AX, this is equal to A cos theta. And similarly your AOI also can be found by using trigonometry. Again, this AOI is this OQ, which is same as this PR. So here from this triangle ORP, sine theta, this is equal to perpendicular PR by hypotenuse, again OR. And this PR, this is same as OQ. So instead of PR, I'll write OQ. And OQ or QO, same. So or this QO or OQ, this is the magnitude AY. So we have AY here, and OR is the magnitude of A vector, which is A. And again by cross multiplication we'll have AY to be equal to A sine theta. So here AY, this is equal to A sine theta. So this is how we resolve vector A into two components. One is along the x-axis and another one is along the y-axis. And we'll have to find the magnitude along the x-axis, which is this A cos theta, and the magnitude along the y-axis, which is A sine theta. So now using these two quantity or two expression, AX is equal to A cos theta, AY is equal to A sine theta, we can find out the expression for the magnitude of the A vector. So here simply what we'll do is we'll just square both these two equations. So AX, if we square them on both sides, you'll get, so I'll square it here, AX square, this will be equal to A square cos square theta. Similarly with your AY also, AY square, this is equal to A square sine square theta. So here you add the two equations, what you'll get is AX. So if you add the two equations, you'll get AX square plus AY square. This will be equal to, so we have A square cos square, A square cos square theta, then plus A square sine square theta. So this one is equal to this simply by adding the two equations. Then what we do is we take A square common, since A square is common to cos and sine, I'll take it common. So a square is taken common. So we have a square cos square plus sine square theta. And this sine square theta plus cos square theta, this is equal to 1. According to trigonometry, this is equal to 1. So this is 1. Hence we have a square to be equal to ax square plus ay square. So this a will now be equal to root over ax square plus ay square. So this is the magnitude of the vector a. So you need to remember this formula. In order to know the magnitude, you need to remember this, and you'll get this one. Now similarly with the direction also, the direction of this vector, that is theta, can be found out by knowing the magnitude of this ax and ay. Now again here, look at this formula. Ax is equal to a cos theta, ay is equal to a sin theta. So if you look at that formula and you divide ay by ax, what will you get? So if you divide this ay by ax, so here we have ay is equal to a sin theta. You divide this by ax, so ax is equal to a cos theta. Now this a cancel. Sine by cos, how much is it equal to? Sine by cos is equal to tan theta. So we have ay by ax is equal to tan theta. Hence this theta can be found out by taking the tan inverse of ay by ax. So here we have tan inverse ay by ax. So your theta is equal to tan inverse ay by ax. So this will give you the direction of the vector A. So we need to remember these formulas. This formula, and this formula. This is the resolution of vector. Splitting a vector A into two parts, ax and ay. The magnitude of ax is a cos theta, magnitude of ay is a sin theta. And the magnitude of this a is found by squaring the magnitude, or taking the square root of the square of the magnitude ax plus the square of the magnitude ay, which is ay square. So now any vector, we've learned that any vector in a plane can be represented as ax I cap plus ay j cap. So this is a vector on a plane. Now if the vector is in space, then you'll have to add another vector. So here we have a vector. This is equal to ax I cap plus ay j cap plus az k cap. Okay, so we have resolved this into three parts. Okay, if this a vector is in space, so we'll have to use another axis, which is the z axis, to get this component az k cap. So the magnitude of this one can be found out by taking the square root of a square plus ay square plus az square. Okay, so if you are asked to find, suppose if you're given a vector, say p, vector is equal to 1 I cap plus 2 j cap plus 4 j k cap, and if you're asked to find the magnitude of p, what you do is you simply take the square root of 1 square plus 2 square plus 4 square. So if you take the square root of this one, you will get the magnitude of P. And if you have only two components, that is AX and AY, or AX and AZ, or AY and AZ, then you simply have only two components, which is AX, AY. Then you have here also only two components, 1 square root of 1 square plus 2 square. Now if we have two vectors, again A vector which is equal to AX I cap plus AY j cap plus AZ k cap, and B vector to be equal to BX I cap plus BY j cap plus BZ k cap. Then the sum of these two vectors, that is R vector A plus B vector, so this R vector is equal to A plus B vector. Then the sum of this R vector can be written by adding the components along the x-axis. So the component of A along x-axis is AX, component of B along x-axis is BX. So simply add AX and BX. So here we have AX plus BX. So you'll have this component along the x-axis. Similarly here AY, BY, AZ, BZ. So we'll get here AY plus BY and AZ plus BZ. Then you have AZ plus BZ. So here AX, BX, this can be taken as RX. AY, BY can be taken as RY. And AZ, BZ can be taken as RZ. So here R vector, which is the sum of A and B, can be written as Rx I cap plus Ry j cap plus Rz k cap. So what is this Rx? It is AX plus BX, Ry AY plus BY, Rz AZ plus BZ. So this is how you will add two vectors if they are represented in this vector notation. So simply add the magnitude of the components along their respective axis.